Hi guys, welcome back. In this lesson, we will complete our analysis by adding our bar chart, which will display the top 10 consumers of water in kiloliters. So let us terminate the server and add the source code for our bar chart. We can also close the browser. Okay, so beneath the bar chart legend function, we can add the code for our bar chart. Okay, so the code that we developed for our bar chart is using the Chart.js library. Okay, so again, we have the function definition, and then we call the function right above. So firstly, we want to create two arrays that will store our data that we want to visualize. So we have the X labeled and the Y data labels. So the X labels will be the suburb name, and the Y labels will be the monthly kiloliter values. Okay, so the values will determine the size of the bars, and the labels will give a name to each value. Okay, so firstly, we need to get our data from the URL endpoint that we have created. Okay, so we will make a standard Ajax call, which is a GET request. So this Ajax call is equivalent to us calling the URL endpoint from our web browser. That's why we add a / and then a top 10 consumers. Okay, so this is standard for a GET request. And then once we have successfully called the URL endpoint, it should return our data. So this is why we have a success function. We also have an error function. So the success function is when the URL endpoint is called successfully and we have received our data. And if not, then we create an error handling function, right? And then we can display a message box. Okay, so we call our alert function, which will display the message box. And then we create a label which says error, and then we append the error message that we get from the evaluate function. So that message box will pop up and we will know what the error is. You can put whatever you want in this function that will help you to describe the error and then ultimately help you resolve it. Okay, so let's go back. So if the function call, if the URL endpoint returned the data and the API call was successful, then we should have the data stored in this variable. Okay, so the next thing that we do is we pass the data into JSON format. So we use json.parse. So we just take the data that we received, which is a sort of JSON format, but we just want to make sure. So that's why we use json.parse. Okay, so once the data is in JSON, then we can extract the labels from the data set. So we have the suburb field, and then we say object.forEach. So we loop through each value inside of the JSON object, and then we extract the suburb name and store it in the X labels array. So we use the push function to insert a value inside of the array. Okay, and then once we have that, we create a new variable called label array, and then we extract the value of the X label. So when we loop through each record inside of the object, inside of the JSON object, the record is still in JSON format. So we want to extract the values without the JSON structure, right? So that's why we create a separate array, a new one, and then we extract the value of X labels, which is the suburb name, and then we store it in the label array. And then we do that for the average monthly kiloliter values as well. So again, we loop through the JSON object with the for each function, and then we extract the average monthly kiloliter values from the average monthly kiloliter field, and then we store each value as we loop through the object inside of the Y data array. So over here we have defined the two arrays, and then we want to make sure that we extract the actual value without the JSON structure. So we create a new array called the data array, and then we say object.values to extract the value, which is the Y data values. So once we have that, our data should then be properly extracted from JSON, and it's no more in JSON format, it's just the values themselves, and we store it in the label array, which is all the suburbs, and then we extract all the kiloliter values and we store them in the data array. Okay, so now we have the data sets that we need to create a chart in Chart.js. So now we just create a context. So this is just standard procedure for creating Chart.js application. You define a context and you say document.getElement by ID. So you are using the canvas that we have created. So if you look at the label, which is horizontal bar chart, we are grabbing the canvas. That's why we gave it an ID called horizontal bar chart. So you need to plot the chart inside of a canvas. Okay, get element by ID, which is the horizontal bar chart, get context. So here you can specify the types of charts that you want, which is 2D or 3D. So in this case, we're using a 2D bar chart. And then the next thing that we do is we define the canvas, which we have already created. And we're saying document.getElement by ID, horizontal bar chart that will grab the canvas. And then we have our parent control, which is the info, which is the legend that we have created. So you can see here we have already created our legend, and we saw that we could display it on our map and it was empty. So we are saying here that we want to plot our chart inside of the info legend. Okay, so now the next thing that we need to do is create the chart. So in Chart.js, to create a chart, it's var, the name of the chart, equals new chart. You pass in the context that you have created, which is the canvas basically. And then the type of chart. So here you define whatever chart you want, pie or bar charts, horizontal, etc. Donut or whatever chart you want to use. And then over here we have the data property. Okay, so here we define the labels. So the labels is all the suburbs that we have stored in the label array, all the suburb names. And that will basically be our X values of the graph. And then we have the data sets. So the data sets has its own properties. So basically this will style the actual chart, the actual bars in the chart. So we add a label for the chart, which we'll call water. And then we add a background color. This will define the color of the bar for our bar chart. So basically it will be the same color more or less as our circle markers. So it's also a blue color, and then the border color as well And then we have the data property, so that will be our y values, which is stored in the data array. So that's the average monthly kiloliter values. Okay, and then we have additional options, so that's how we want to style the actual chart as a whole. So basically we just want to set the lines in our graph. So it's a standard property for every chart that you will create. If you want to create grid lines, etc., at each label. So here, for instance, we just saying that we want to begin counting from 0. Right, so our average monthly kiloliter value, the lowest value will be 0. That's why we have begin at 0 equals true. This is not necessary for our X labels, which is just a suburb name. So it's not really a value, but we have just added it. So that basically is the scales property. Okay, and then we show values equals true. So we want to display numbers with each scale. So for instance, when we begin at 0, we want to display the 0 value, even though 0 is not contained in our data set. Okay, so that's basically what that means. So that marks the entire chart. So now let us test and see if we can successfully call our URL endpoint and then get our data in JSON format, extract it, and then create our chart. So let us run the server and then confirm whether or not we created our chart. So Python manage.py run server. Actually, what we needed to do was save the file. So I can see that the file isn't saved. So Control S and then run the server. Okay, so now let's open up the URL link. Okay, so as you can see, we have successfully created our bar chart. So the values start with a 0 and we have labels for each kiloliter value, which ranges from 0 to 14. Okay, so Chart.js will just look at our data values and then define the range of the data values for us automatically. And then over here, we can see that we have our top 10 consumers of water for this month. Okay, and it's sorted in descending order because that's what we did in our views.py file. We extracted the data and then sorted it in descending order and then extracted the top 10 data values. So that is what we have over here. So now we know the top 10 suburbs that are consuming the most water for this month, and that is the suburbs that we should be paying attention to. And then we also have the legend that can further help us identify the values of the circle markers, right? So that basically marks our entire application. So feel free to expand on it and then customize it to your own needs. So that concludes this course. I hope you guys have enjoyed it as much as I have enjoyed creating it. And I will see you guys in the next course. Thank you.